Howdy guys. So in this video we're going to go over some UV mapping and some procedural and non-procedural ways to create UVs for our assets in Houdini. For those who aren't familiar with UVs, UV mapping is the 3D modeling process of projecting a 2D image to a 3D model surface for texture mapping. We generally use the letters UV and occasionally W to denote the axes of the 2D texture, since X, Y, and Z are already used to denote the axes of the 3D object in model space. A UV texture permits polygons that make up a 3D object to be painted with color and other surface attributes from a normal 2D texture image. So Houdini offers quite a few ways to generate UVs for procedural assets. So in this video we're going to start taking a look at what some of those features are and how to use them in different scenarios. So first off, let's go ahead and drop down a grid so that we have something to reference with our UVs. And we're just going to dive inside here, and I'm going to actually split my pane left and right, and we're going to start looking at press 5 on my keyboard to go to the UV preview. So we've got our geometry on this side and our UV space on the side, and here we can see our UV grid. To see this UV space projected onto our UV grid, I'm just going to throw down a UV Unwrap node. And this is Houdini's automatic UV generation for creating simple and quick UV previews and UVs. So in order to see our grid projected onto our UV space, we'll actually need to drop down a UV quick shade, and we'll see that now we can see our UV space projected onto our grid in our 3D viewport. Now, UV Unwrap is a very quick and quick and dirty way to UV objects. Sometimes it works really well, but sometimes there's some non-uniformity, or it unwraps things and we can't control the seams the way that we would need to for more complicated geometry. Obviously, for a flat grid, this works pretty okay. Another way that we can do this is using a UV project node, and we'll come down in here and we'll see we have a bunch of different projection methods that we can use to project our UV grid to, and then we can modify the rotation of this grid on a plane and the scale. These operations are much more limited on the UV Unwrap. And there's a lot of different ways that we could unwrap this. We can look, and if we press enter in here, we can see what exactly it's trying to do with this polar, or you'll see it looks like a spherical unwrap for our grid here. So obviously this isn't really going to work. Could try the same thing with cylindrical unwrap, and it will try to UV unwrap our grid by projecting a cylinder towards the geometry around our object. Again, so UV project works really well for unwrapping spheres, cylinders, toruses, or even some objects like rocks or something with its plastic wrap feature, which tries to basically create a larger, roughly shaped object and then shrink wrap it to project the UVs around it. We're going to go ahead and stick with orthographic, and we'll move on to some more complicated geometry like a box. So for our box, let's go and drop down a UV Unwrap just so we can see what this is doing. And we'll see when we drop down the UV Unwrap, it's taken each of our faces, the 6 faces on our box, and UV unwrapped them into our UV space. And we can increase or decrease the spacing here to get rid of the seams, but this doesn't really give us a lot of control over which faces or edges are being cut for our UVs. So there's actually another way that we can do this, and that is with the UV Flatten node. And UV flatten, we'll see we get an error soon, or a warning as soon as we get it, and it's because we have no boundary seams selected for our object to flatten. If we zoom in on this node here, we can see it looks like a little pair of scissors cutting across an edge on a cube. So we need to select the edges to cut for our UVs on our cube. And to do that, we can just select a group of edges. And I'm going to quick select these to demonstrate, but we could use a group node to and some parameters to procedurally select the seams for our groups to be UV'd. So to select the seams, I'm going to hit this little white arrow here and go to my 3D viewport. And I'm going to press 3 to start selecting edges. And I'm just going to start selecting edges so that I can UV unwrap this so it looks like the typical box, like we were going to make a box out of paper, how we would cut it to see that cross shape. And I'll hit enter once I have my edges selected, and we'll see that I now have a cross-shaped UV layout for our cube. And I can go and put another UV quick shade down, and we'll see it's not distorted, but its angle is off. We can fix this in a couple of ways. We can do a UV transform node, and in our UV transform we can see what axes it's going to be on the z-axis, and we'll rotate this up by like 64 degrees or so, and then we can translate it and move it to where we need it to be on our grid. So just like the transform node in the geometry space is used to manipulate the scale, rotation, and transformations of objects in 3D space, the UV transform node behaves similarly in the UV space. And let's take a look at another way that we could, another node very similar to the UV flatten node that can do a similar operation for our box, and that is the UV pelt node. So pelt works generally best for organic objects, but it can work for something like a cube also if we wanted. So I'll go ahead and select our cut group similarly to how we did our UV flatten, and I'll just go through and select the same edges as I did before. Alright, I'll hit enter, and now we'll see it has basically not only cut the edges and unfolded them, but it's now stretching them as if it was like we were skinning a rabbit. So we can see by modifying the spring amount how much it stretches our UVs, and we can change the way that it is pelting through different algorithms here. So once we have this pelt, we can actually drop down a UV edit node, and this is similar to the edit node for geometry, just how we can use the edit node to manipulate points non-procedurally. In the 3D viewport, we can use a UV edit to do a similar operation for our UV space. So I'll go ahead and have my edit node selected, and I'll hit enter. And now we'll see I'm able to select and modify geometry here, just like I could in 3D space. You'll also notice that I've selected an edge, and that is now moving this edge and this edge because these are the same edge in the 3D viewport. So it's going to have to translate each edge. But if I select 5 in my viewport, then I can go over to edit vertices. And now I can click on the vertices, and I'll have full control to change the spacing of all of my vertices on my UVs. And we'll notice I can click in the middle of the space and move these blocks around freely if I want and create different islands. And if I want to snap one vertice to another, I can eyeball it, or I can press X and go to point snapping. And then I can click on my vertices, and it will snap them to the nearest point. and that's not perfect, but it's good enough for now. So we can bring this into our UV quick shade and see what it's doing here, and we'll probably do a UV transform as well to just rotate it and move it up. And again, it's not perfect. UV pelt, like I said, is much better for non-uniform geometry, organic shapes like rocks and such. But it is another way and behaves similarly to UV flatten. So now let's take a look at UV unwrapping tubes. So go ahead and make a tube. And there's a couple of different ways that we could do this. First off, let's make our tube not start as a primitive. We'll notice that each primitive is defined by a single point in space and a mathematical formula to determine the surface shape of our shape. So because UVs require vertices, they are a vertex attribute, they require multiple vertices, or then thus multiple points, in order to have UVs. So primitives cannot hold UV information. We will need to be using a polygon or a NURB or something like that. So I'm going to use polygons. And I'll just increase the height here a little bit, and maybe the rows. Okay, so I've got a tube, and I'm going to add end caps, and we'll see what happens to our tube when I throw a UV unwrap on it. And we'll throw this down, and I'll do a UV quick shade so that we can see it on our model. And it looks okay. It's not distorted. There's some weird seams here. But our cubes, our boxes, are pretty square. This is a sign of a good UV. We don't want the boxes to be deformed on our geometry, because that tells us that we're getting some stretching in our UV space. So one thing that we'll notice when we take a look at our tube, if I were to have this tube as a procedural asset and I'm changing the number of rows, we'll see that our UVs are jumping around and changing as this changes. This is really hard to manage when you're trying to create materials or procedural materials in UV space for a procedural asset. It's almost impossible to manage, really. So we're going to look at a couple different ways to UV unwrap a tube that is much more simply managed. So first, let's look at the UV texture again, and we'll see it starts out as orthographic, which is not what we want. We're just going to get, if I quick shade on this, we'll get great UVs on the top and the bottom, but it's just doing a planar projection down, and then we're getting incredible stretching and almost basically no UVs for all of our sides. But remember, we have cylindrical unwrapping here, and that looks pretty good. But we're getting this seam. So what's happening here, if I hit D in our viewport and I turn on UV overlap, we'll see that it has changed to a bright red. And if I turn on point numbers, we'll see our points are lining up here, and we're not getting any double points lining up over anything. And we'll see if I turn on points here, not primitives, points. Alright. This seam, 0, 12, 24, 36, lines up over here. And we'll notice that even though they share points, the vertices are also shared. So what's happening is our boundary for the vertices for these points is stretching all the way from here to here across our entire UV set, and thus we're getting the entire rest of our grid. So here, A2 to 14, and if I turn off my distortion, this will be easier to see. So we're stretching from A2 right here, and then if we zoom in, we can see A14 right here. So it's actually stretching all the way across this section here. In order to fix that, I'll turn on UV distortion again, or overlap. We can just check the fixed boundary seams, and it will make sure that the texture wraps around correctly and moves the vertices to their appropriate end of our UV unwrap. And there we go. Now we have clean, non-overlapping UVs on the sides of our tube. And we'll go back to our tube and we'll see that I can change the rows as much as I need and the columns as much as I need, and I get pretty good results through and through. Our squares look a little flat. This could be okay because they're uniform, but if I wanted to square them, the UV texture has its nice scale attribute, so we can just scale this down until we get some good square results. And now we'll see as I adjust my height, it's still stretching again. So we could, if we wanted, to copy our height parameter to our UV texture and paste this as a relative reference here, and find a multiplier that gives us relatively square output. So we're going to say 0.2. And now as I adjust our height, I'm continuing to get square UVs as my tube grows in height. That's really nice. Alright, but now we have a problem. Our end caps don't look too great. And that's because we're getting the same issue that we had with our UV unwrap, or not our UV unwrap, our orthographic projection. And that's that we're projecting from one end, but our sides are all being deformed. So we move this back. So we're projecting from the sides of our cylinder, but not from the top or the bottom. So in order to fix this, what we'll need to do is actually go ahead and blast our geometry. And I'm going to say 0 and 1 for now, because I know that's the top and the bottom. Those are the end caps of my tube. We're going to blast those away and only perform this UV operation on the sides of my tube. And then I'm just going to copy this blast, and I'm going to choose delete non-selected. And then we'll go over to our blast here, and we'll see now I only have my end caps. But because we know that the UV unwrap worked pretty great for our end caps, or heck, even the projection, the UV projection for our UV texture. So I can just do a UV unwrap on my end caps here, and now we'll go to our quick shade, and those look pretty good. But now we've got two different geometries, so now that we've UV'd each piece independently, we can merge them back together and put them back in our UV quick shade, and we've got some good UVs here. But notice we're getting some UV overlapping here. UV overlapping doesn't really matter, like the textures don't care if the UVs are overlapping or not, but if we need them to have separate UVs, obviously they can't be overlapping in the one-to-one UV space. So what we'll need to do after we merge this is fuse our geometry so that we can merge our overlapping points. We have 168 here because we broke them apart. And so when we go to our fuse, we'll see we've now combined our overlapping points. And then we can just drop a UV layout node, and this will lay out our UVs very nicely so that they no longer overlap. And we go to our preview, and we'll see that we now have some nice, clean, uniform geometries. And we can check the correct island area properties to try to normalize the size and scale of the grid for our unwrapped geometry. And we'll see this still works great as we change the height and rows and columns of our tube. Alright, so now let's take a look at UV unwrapping some spheres. Now, spheres are very complex geometry in and of themselves because there's so much data and goes into creating a smooth spherical object. And once again, with this as a primitive with only one vertex and one point, so we'll need to convert this to a polygon or polygon mesh. I like polygon meshes. I think they're easier to work with and easier to UV unwrap. And we can get some cleaner geometry if we end up only needing part of the sphere rather than the polar caps. So let's take a look and see what the UV texture orthographic looks like for a sphere. Obviously, it's just going to be a projection down, and we just get it from this angle, and that's not anything like what we want. But if we select our polar option here, we'll see that we're getting closer, but again, we're getting our boundary seams. So if I put a UV quick shade up, we'll get this, and it looks pretty okay. But again, we get this wraparound, so we can fix that with our fixed boundary seams. And there we go. But again, we're going to get some distortion up here at the top of our sphere. And this is kind of an unavoidable problem with UV unwrapping spheres. There's a lot of more complicated techniques and UV unwrapping algorithms to solve this warping of the UVs at the pole. Usually it is left and then compensated for in the texture. Let's look at some other ways to UV unwrap a sphere. We can just do a simple UV unwrap. And we'll throw this down and see how it affects. And we get pretty good non-distortion here, but we have very little control over our seams. Even when we start controlling the number of planes that we get, still good distortion. Our cap down here looks pretty good, but it's not a whole lot of control, really. So we could also use our friend, the UV flatten node, to try to do our own kind of unwrap by selecting a better seam for us. So we can go to our seam groups and select edges, and I'm just going to click here and shift, and I'll double click down the line to select the entire edge loop right here, and I'll press enter, and we'll get this UV unwrap right here. And this is getting some massive distortion here. So this method may not be the best for unwrapping spheres. And if we were to go and select a new edge group, let's do something like this. Maybe I'll leave that and select that ring, and then we'll select this ring as well. I'll just hit Shift A, and then I'll just drag around the loop here to select our loop. And I'll just keep going once I get to the halfway point. And unselect that. And now that I've got my end caps, we'll hit enter, and we'll see I get much less distortion, still a little bit, and we've now cut our end caps themselves off. So obviously you'll see that this distortion would decrease dramatically as we cut our end caps off. The further down the end caps we go, the less distortion we would get on our unwrap. Another way, very similar to the UV texture, is the UV project, not pelt, UV project. And we'll see if I set this to a polar unwrap, it automatically fixes our boundary seams and pole overlaps, and is properly centered on our UV space. But again, we still get this polar distortion. So now let's take a look at using a sweep node and some UV textures to unwrap swept curves along an arc length spline. So I'm going to drop down a curve, and let's go ahead and go to top view real quick, and I'll just draw curve. That looks fine. And we'll go back to top view, perspective view, and I'll go ahead and add another line. And we'll have this go in the positive X direction. And I want my line to be centered on the X axis. So I'm actually going to take the length and do the negative of the length times half. Negative. There we go. So now as I make my line longer, it will stay centered on my X axis. Let's make this a little bit smaller, so I don't know, like 0.25. That'll be fine. And then I'll just make a sweep, and we'll connect our backbone. And now I've got my my line swept across my backbone. And I can go ahead and throw down a UV quick shade, and we'll see that it actually comes once I go ahead and output, and we'll just skin this. We'll see that once I skin it, the sweep node actually generates UV attributes for us by projecting orthographically down onto our curve. But this is pretty uniform. There's not really like massive distortion or anything right now. But this makes it really hard to texture if we wanted to do this like a road and get like straight lines that curved across our road. So we're going to look at a different way to UV unwrap this curve as if it were a nice straight line. And the function to do that is arc length. So I'm going to go ahead and resample our backbone curve here. Maximum points I'll set to something like, I don't know, 25 or 30 to get some more distortion in there, and we'll make this subdivision curves so it's a little smoother. And then I'm going to go ahead and we're going to have to convert these from polygons to NURBS so that we can use the arc length function. And we'll just go to our convert that to a NURBS curve. I'll copy this over, and you'll notice that as I convert these over to NURBS, it actually breaks our sweep, and that's because the sweep operation works in polygons. So we'll actually need to make a little change here and put some conversion back to polygons after we do our UV operations. And we're going to drop down a UV texture. And inside of our UV texture, we're going to set this from orthographic to arc length spline. And I'll turn on points over here so we can see what's happening, and point numbers. And we'll see it's right now getting it in a straight line, but we have no Y depth or height in our UV offsets. And also, if we take a look at our UV set here, I'm getting some interpolating points in our line, so I'm just going to drop our UV order down to 2 to get rid of that, because I don't want to add any extra points there. Probably going to get something similar here, not really, but I'm going to leave that on a UV order 2 anyway. And if we go back to our UV texture, we'll see we're getting points here and here, but I want this to stretch vertically this way and then go down to the right in a straight line. So we're going to rotate our UV texture here by an angle of like -90, and now we'll get this way, and now we just need to set the distance of our UVs along our arc length spline. So we're going to change our attribute class here to points so that we can get the UV information through our point attributes. And we'll set the scale of our UVs to arc length, and then the path to our node, which is line 1. And then we're going to go from 0 to 1, so the beginning and end of our curve, at no interval, so the entire curve. And now this is setting the height of our line, of our UVs, to the height of the entire straight length of our line. And this is working fine, and we really could just relative reference this length to our UV texture, because these values are going to match up because it's a straight line. But let's see how arc length works on something that is not straight, like our backbone curve that we have here. So instead of an orthographic, we're going to go back to arc length spline, set this to points, and then we'll do arc length, and we'll grab from our resample, and we'll go 0 to 1 with no interval. And we'll see now we're getting the entire curve straightened out with even intervals between them. And then we can step down to our sweep. And we're not going to get anything right now because it is iterating through all of our primitives at each point. But we want it to go one primitive at a time. We'll see that once we do this, we get a nice straight line of our curve. And this is much easier to apply materials and textures to than the simple orthographic projection that we had before. And we'll see we're getting some really nasty overlapping primitives here. And this is because we're iterating through each primitive on a polygon one at a time. And we can fix this just by going up to the top of our curve and initializing it as a NURB surface. And then when we step through our resample, we'll set this along straight edges. And then we'll go through our convert nodes and tell them to interpolate through holes. And we'll see that once we have this set, we'll get nice even points along our curve and none of the weird geometry overlapping, and we still have a nice straight UV unwrap. So that's a quick overview of how to use simple UV operations for procedural assets in Houdini.